Hello friends, welcome back. Let us continue with the properties of the alkali metals. Next, let us see reactivity, the reactivity of alkali metals. Reactivity of alkali metals. Okay. As you know, alkali metals are highly reactive. They are highly reactive. And the high reactivity is due to the very large size of the atoms and the low ionization enthalpy. Alkali metals are found to be highly reactive metals. And the high reactivity is due to the large size of the atoms and low ionization enthalpy of the atoms. So all these are highly reactive. As you know, the alkali metals can react in air. When exposed to air, alkali metals, when kept exposed in air, they react with the air and moisture and get tarnished. They get tarnished. When kept exposed in air, the alkali metals get tarnished. The silvery white or silvery gray color, the shining appearance is gone and they are tarnished. The tarnishing is due to the reactivity of alkali metals with the air and moisture. They react with the air with the formation of a metal oxide. The metal oxide then reacts with moisture with the formation of a metal hydroxide. So due to these reactions, alkali metals are easily tarnished. The brightness, metallic luster is gone. That is due to the oxidation of the metal with the formation of the metal oxide. And the metal oxide dissolves in moisture. It reacts with moisture with the formation of metal hydroxide. That's why the alkali metals get tarnished when kept exposed in air. Due to the high reactivity of alkali metals with the air and moisture, they are kept in kerosene. Alkali metals are kept in kerosene. We have studied this in the 10th standard. Alkali metals are kept in kerosene. That's because alkali metals are highly reactive. They react with the air as well as moisture with the formation of metal oxide and hydroxide. So to avoid this reactivity, or to protect the metal from this reaction, alkali metals are kept in kerosene. They are highly reactive, then they can easily burn in air. When alkali metals burn in air, there will be the formation of the corresponding metallic oxide. There is a formation of the corresponding metallic oxide. The corresponding metallic oxides will be formed. Corresponding metallic oxides. For example, take lithium. Lithium burns in air with the formation of lithium monoxide. lithium monoxide. While sodium, sodium reacts in air, it burns in air with the formation of a peroxide. So lithium gives lithium monoxide a Li2O. Lithium burns in air or oxygen with the formation of a lithium monoxide, while sodium burns in air with the formation of a Na2O2, and this is peroxide. Sodium peroxide. You take the other metals, say for example, potassium, rubidium, cesium, etc. Potassium, rubidium, cesium, etc. They burn in air with the formation of superoxide. For example, KO2 or RbO2 or CSO2. These are superoxides. Superoxides. So lithium burns in air with the formation of the monoxide. So lithium is the lithium is the only metal, alkali metal, that gives monoxide, while sodium burns the formation of a peroxide, Na2 to peroxide, while potassium, rubidium, and cesium give superoxides like KO2, RbO2, CSO2. Let us take the case of the superoxide. For example, KO2, you take a KO2, potassium superoxide. In potassium superoxide, potassium is in the +1 oxidation state. And O2 is the -1 state. O2 is in the -1, that is in the -1 state. That is in the -1 state. O2 -1. That is why K plus O2 -1. Okay. So potassium, rubidium, and cesium, they give superoxides, while sodium gives peroxide and lithium gives monoxide when burns in air. Okay. Now let us see the action of ammonia. Alkali metals, all the alkali metals can dissolve. They can dissolve in ammonia, giving a very deep blue solution. Alkali metals dissolve in, say, liquid ammonia. So action with liquid ammonia. In liquid ammonia, alkali metals dissolve, forming a deep blue solution. Alkali metals dissolve. They dissolve in liquid ammonia, forming a deep blue solution. And let us see the properties of a deep blue solution. The properties are this. First of all, the deep blue solution is paramagnetic. It is a paramagnetic. Solution is paramagnetic. I shall explain what is meant by paramagnetism. Paramagnetic. The deep blue solution is a good conductor of electricity. That is also good conductor of electricity. Let us see paramagnetism. What's meant by paramagnetism? Certain substances are attracted towards an external magnetic field, And that phenomenon is called paramagnetism. The attraction between a substance and external magnetic field. That's called paramagnetism. Some substances are attracted, they are attracted towards external magnetic field, external magnetic field. And this weak attraction, that is called a paramagnetism. Paramagnetism, they are paramagnetic. Paramagnetic substances will contain unpaired electrons. There will be unpaired electrons. So paramagnetism is a sign of the presence of an unpaired electron. Coming back to the blue solution, say alkali metals dissolve in liquid ammonia, forming a deep blue solution. The deep blue solution is paramagnetic, and it is a good conductor of electricity also. Let us see paramagnetism. It is the phenomenon by which certain substances are attracted towards external magnetic field. Attraction between the substance and external magnetic field. That's called paramagnetism. And some substances are paramagnetic substances. Attraction by the external magnetic field. That is paramagnetism. Paramagnetic substances contain unpaired electrons. There will be unpaired electrons in the paramagnetic substances. So paramagnetism is an indication of the presence of unpaired electrons in the given substance. Now, conductor of electricity, and that is due to the presence of mobile ions as well as electrons. Let us see the structure of the deep blue solution. See the structure of the deep blue solution. You know, the deep blue solution consists of ammoniated ions and ammoniated electrons also. In the deep blue solution, there will be ammoniated ions. The deep blue solution contains ammoniated ions and ammoniated electrons. It's important. Ammoniated electrons. It's a very important point here. Ammoniated electrons. So that is the reason for paramagnetism. Say a metal, M, alkali metal, say lithium, sodium, potassium, whatever it is, M. And this reacts with the ammonia, NH3, ammonia. There is ionization for the metal M. The metal M is ionized. For example, take sodium. Sodium ionizes, giving Na plus one electron. So in general, M first ionizes, giving M plus one ion, unipositive ion. You have seen that in the beginning. Unipositive ion plus electron. See, electron. Now what happens? These M plus one ions, these are covered by ammonia. You think of hydration, covering by water molecules, hydration. Here there is a covering by ammonia molecules. And that is called ammoniation. hydration, ammoniation. So it is an ammoniated ion. An ion, here plus one ion, Na plus one, or as K plus one, or Li plus one. The positive ion is covered by ammonia. And such an ion covered by ammonia, that is called ammoniated ion. Similarly, the electron is also covered by ammonia, NH3. And this is an ammoniated electron. So there are ammoniated ions and ammoniated electrons. What is meant by this? The ion is covered by ammonia molecules. That is an ammoniated ion. Electron is covered by ammonia molecules. That is ammoniated electron. Due to the presence of ammoniated ion and ammoniated electron, the deep blue solution is a good conductor of electricity. You know, for electrical conductance, there should be free ions, mobile ions, free ions in the ionic compounds or ionic substances. There should be free ions. Here, the ammoniated ions are mobile ions. Similarly, the ammoniated electrons, they are also mobile electrons, free electrons. And due to the presence of free mobile ammoniated ions and ammoniated electrons, the ammonia solution of alkali metals are good conductors of electricity. Come to the paramagnetism. You look at the structure of the ammoniated electron. The ammoniated electron is a single electron. That is an unpaired electron. That is a single electron. That single electron is covered by ammonia. Due to the presence of unpaired, ammoniated electron, the blue solution shows paramagnetism. We know in the paramagnetic substances, there will be unpaired electrons. You underline that in your minds. If a substance is paramagnetic, attracted towards the external magnetic field, there should be unpaired electron. So here the solution, the deep blue ammonia solution of alkali metals are paramagnetic due to the presence of the unpaired ammoniated electrons. Okay, that is why it is paramagnetic. Then the blue color. How is the blue color produced? The blue color is due to the presence of ammoniated electrons. The ammoniated electrons absorb visible radiations. And the electron gets excited. Due to the excitation of the ammoniated electron by absorbing visible radiation, the solution gives the blue color. So three things you have to remember here. One, the ammonia solution of alkali metals is deep blue in color. It is paramagnetic. It is a good conductor of electricity. 3 points. The blue color, that is due to the ammoniated electron. It absorbs energy from the visible region. and there is excitation of the ammoniated electron, and that's why it gives the blue color in the visible region. Second, paramagnetic, attracted towards the external magnetic field. It is due to the presence of unpaired, even if you are sleeping. If somebody comes and asks you when you are sleeping, why a substance is paramagnetic, immediately you must say, it contains a Vidor, it contains a
Unpaired electrons.
unpaired electron. That's the answer everywhere. Everywhere, that's the answer. Okay? Unpaired electron. This electron, the ammonium electron is a unpaired electron. So it is a paramagnetic. Then electrical conductivity. That is due to the presence of free ammoniated metal ion and ammoniated electron. Ammoniated electron and ammoniated metal ion. So due to this, all these are a mobile or a free ion and a free electron also. That's why the blue solution is a good conductor of electricity. But when it is kept for a long time, the color slowly changes and it becomes bronze color and it becomes a diamagnetic. So another term comes here, diamagnetic, diamagnetic and a diamagnetism. Diamagnetism, we need this for the second year. We need diamagnetism, that is needed. What's meant by diamagnetism? Certain substances are repelled away from the external magnetic field. When the substance is brought towards external magnetic field, then what happens? Repelled away, repelled away from external magnetic field. External magnetic field. And that property is called diamagnetism. The repulsion between the substance and external magnetic field. That is called diamagnetism. And such substances are diamagnetic substances. If a substance is diamagnetic, then we can say that all the electrons are paired electrons. There is no unpaired electron. There is no unpaired electron. There is no unpaired electron. All the electrons are paired electrons. There is no unpaired electron if a substance is diamagnetic. So you have seen two terms here regarding magnetic property. Next year you need this, not only in chemistry but also in physics. You need this paramagnetism and diamagnetism. I repeat, the weak attraction between a substance and external magnetic field, attracted towards external magnetic field, that is called paramagnetism, and such substances are paramagnetic. Paramagnetic substances contain unpaired electron. Then certain substances are repelled away from external magnetic field. Repulsion between a substance and external magnetic field, that is called a diamagnetism. And such substances are diamagnetic substances. Diamagnetic substances do not contain unpaired electron. All the electrons will be paired electrons. What is meant by paired electron? Do you remember the spin of the electron? Remember, clockwise spin, anti-clockwise spin, plus half, minus half. Okay. If the electrons are paired, the electrons have opposite spins. One is having clockwise spin, the other is having anti-clockwise spin. One is having the spin quantum number plus half, the other is having spin quantum number minus half. So it is a spin paired. So whenever there is pairing of electrons, there is pairing of the spins. The spins will be paired. That means the spins of the pair of electrons will be opposites. One is having the clockwise spin, another is having anti-clockwise spin. Okay. In the diamagnetic substances, there is no unpaired electron. So remember these two terms. Okay. Now let us see some of the uses of the alkali metals, some of the uses of alkali metals. For example, take lithium, uses of lithium. So many uses are there. It's a very important use. Can you say important use? You use it every day. Even now you are using it. Even
That's
now.
right, sir.
That is in the cell, the lithium cell, the lithium ion cell. Lithium ion cell, the cell, the rechargeable cell that you are using. The rechargeable cell that you are using. That is the lithium ion cell. Say large work is going on in the solar cells, the lithium cells, etc. Now, this year's Nobel Prize in chemistry, it goes for the work in the lithium ion cells. This year, yes. So it is being under modification. You can also do the modifications in these cells as well as they say the panels also, solar panels also. You can do a lot of work. There is enough space for doing the research work. My dear friends, it is not compulsory that all of you should become the simple engineers or the ordinary MBBS doctors. No, there is a large scope. See, the field of science is vast. There is enough space for you. You can do a lot of research work other than the simple ordinary MBBS or the ordinary BTech. BTech, you can do a lot of work in this field. So try for that also. That is my opinion. That is my advice. Okay, that is left to you. Okay. So lithium ion cell, lithium is used in the lithium ion cell. Another one, it is used in the thermonuclear reactions. Used in thermonuclear reactions. Thermonuclear reactions. The nuclear reactions, chemical reactions and the nuclear reactions. What's the difference between these two? Chemical reactions means a change in the electronic configuration. A change in the electronic configuration, that is a chemical change. That means electron is either completely transferred from one atom to the other. One atom loses electron, the other atom gains electron, or there is sharing of electrons, covalent bond. So in a chemical change, there is a change in the electronic configuration. That's a chemical change. It has nothing to do with the nucleus of the atom. But what's a nuclear reaction? A nuclear reaction is one in which there is a change in the composition of the nucleus. A change in the composition of the nucleus. That means a nucleus is converted into another nucleus or another atom. Transmutation. Nuclear transmutation. One atom is converted into another atom. An element is converted into another element. That is the nuclear transmutation. And that is a nuclear change. So the change in the nucleus. A nucleus is either split into two small nuclei, fission reaction, or small nuclei are combined together, giving a larger nuclei, fusion reaction. For example, hydrogen bomb. Hydrogen atoms are fused. Nuclei are fused. Fusion reaction. That is also a nuclear reaction. Similarly, during radioactivity, alpha or beta ray emission, an atom is converted into another atom. Alpha ray is gone or beta ray is gone from the nucleus. It is going from the nucleus. Radioactivity originates from the nucleus. So during radioactivity, alpha and beta ray emissions, say one atom is converted into another atom. A nucleus is converted into another nucleus. And that is also a nuclear transformation or a nuclear reaction. The transformation can take place by spontaneous disintegration, natural radioactivity, or we can convert a nucleus into another nucleus by bombardment process. A stable nucleus is bombarded with a projectile particle, and then it is converted into another nucleus. Artificial transmutation. So all these are the nuclear reactions. And the thermonuclear reactions, lithium is used as a projectile particle. Okay. Let us take a sodium. Use of a sodium. So many uses are there. I take only very important special use only. Say liquid sodium is used as a coolant in fast breeder nuclear reactors. It is used as a coolant in nuclear reactors. In nuclear reactors, there is nuclear fission reaction. And during the nuclear fission reaction, large amount of energy, heat energy is released. That is the nuclear power stations. There we produce heat energy by means of a nuclear fission reaction. And this heat energy is utilized for the production of steam. And that steam is used for the production of electricity. Instead of water, we make use of steam. And that is the nuclear power station. Kodambakam, for example, nuclear, there is the new one, dispute of Tarapur, another one, Tarapur, or say Trombe, Baba Atomic Research Center. Or in all these places, there are such nuclear reactors. Okay, so the liquid sodium is used as a coolant. That is to slow down the neutrons. Then you take cesium. Cesium is used in the photoelectric cells. Potassium also. Photoelectric cells. Cesium is very commonly used. Potassium is also used in this. Potassium chloride is used as a fertilizer. NPK mixture. So KCl, that is used in the potash fertilizer, and KOH is used as carbon dioxide absorbent. Okay. Think of the superoxide. Say KO2, KO2 minus 1 superoxide. KO2 minus 1 superoxide. Superoxide is paramagnetic. It is paramagnetic. Can you say what the reason is? Anna, it is a paramagnetic. Can you say? It is a paramagnetic. You have to make a correction in the notes. It is minus 1. It is a paramagnetic. Can you say what the reason is? Vidur, superoxide is paramagnetic. Can you say?
Unpaired electrons.
Unpaired electron, yes. And the unpaired electron is in the pi star 2p molecular orbital. Just to remember, at least there is unpaired electron. Okay. Let us take two more salts, and after that we can finish this class. Take two more salts. Say one is sodium nitrate and the other is potassium nitrate. Sodium nitrate and potassium nitrate. Let us take these two salts. Sodium nitrate, NaNO3, sodium nitrate. Then potassium nitrate, KNO3. When sodium nitrate is heated, it decomposes with the formation of a NaNO2 plus O2. And this is a sodium nitrite, ITE. See the spelling, NITRITE, nitrite. If you want, you can balance the equation like this, 2, here also 2. Similarly, when potassium nitrate is heated, it decomposes giving potassium nitrite, KNO2 plus O2, KNO2 plus O2, potassium nitrite, KNO2 plus O2. Okay. And this reaction can be employed for the oxidation purpose. You know, in gunpowder, what is gunpowder? An explosive. It contains a mixture of a carbon plus sulfur plus potassium nitrate. This mixture is a gunpowder explosive. Gunpowder, a mixture of a carbon powder, sulfur powder, and potassium nitrate. That is a gunpowder. It's used as an explosive. Say in the gunpowder, potassium nitrate is used, while sodium nitrate is not used. That is not used. That is because sodium nitrate is deliquescent. This compound is a deliquescent. Sodium nitrate is a deliquescent. What is meant by deliquescence? Deliquescence means absorption of moisture and becoming wet. To become wet by absorbing moisture from the air. That's called a deliquescence. And such a substance is called a deliquescent substance. Sodium nitrate is deliquescent. It will absorb moisture. If it absorbs moisture, what will happen to the gunpowder? The gunpowder will become wet. But it cannot work as an explosive. While potassium nitrate is not a deliquescent. Okay. There are some common names for these minerals, sodium nitrate and potassium nitrate. Sodium nitrate is called a chili saltpeter. Sodium nitrate, that's called a chili saltpeter. And while potassium nitrate, that is called niter or Indian saltpeter. Usually saltpeter, sometimes known as Indian saltpeter. Indian saltpeter or simply saltpeter or niter. So remember these names also. Chili saltpeter, sodium nitrate, then niter or a saltpeter or simply Indian saltpeter, that is potassium nitrate. So that's about the some of the compounds of alkali metals. And say it finishes the chapter group 1 alkali metals. This is enough for us. The alkali metals group 1. We have seen the members of the group. We have seen the electronic configuration. We have seen some of the properties of alkali metals, etc. And we have seen some of the compounds also. So it finishes alkali metals or a group 1. Tomorrow we can see alkaline earth metals or group 2, And there are some more simple portions, and that's four of the P block elements. Four of the P block elements. That is a group 13, 14. Yes, 13. Only two are there. Yeah, I thought that there are four. Only, only two are there. Group 13 and group 14. So by that, our classes will be over. Then we can start the revision. Okay. So let me stop now. Meet again. Thank you.